Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. My name is Ahmad Daniel bin Mustafa, and as for today, I'll be presenting about the client-server computing assignment 2, which the topic is RMI and Corba in client-server applications. So first off, we will start with the introduction. So client-server architecture enables communication between computers, whereby middleware helps manage object communications, serialization, naming services, and network protocols. There are also two important middleware technologies, which is Java RMI and Corba, and its purpose is to understand implementation of RMI and Corba to compare both technologies and determine suitable use cases. Moving on to Java remote method invocation. Java-based distributed computing technologies allows methods to be invoked on remote objects. It works between different Java virtual machines or JVMs, and the main components are client, server, remote object, and RMI registry. It is also best for Java to Java communication. So for RMI architecture and flow, you might be wondering how does RMI works. So firstly, client will request remote service, and then RMI registry locates remote object. Then client will receive the stub reference, then stub marshals data into stream. Therefore, the request will be sent to server skeleton and server will execute method and the results will be returned to client. So here are also some of the important terms such as stub, which means client-side proxy, skeletons, which means server-side handler, and lastly, marshalling, which converts data into transferable format. Moving on to simple remote interface. As you can see on the left side is the example of the coding. So as we can see, the remote interface extends remote, and then methods will throw remote exception, and client can call server methods remotely. So here are also some of the advantages of RMI. So one of the benefit of RMI is that it is very easy to be integrated with Java applications. It also supports object serialization, distributed garbage collection, and dynamic class loading. It is also faster in terms of development in Java environments, and it is mostly suitable for enterprise systems, internal corporate applications, and also rapid prototyping. So moving on to the next part, which is Corba. So what is Corba? So Corba stands for Common Object Request Broker Architecture, which it is vendor neutral distributed architecture. It also enables communication across different programming languages and different operating systems. One of the main components of Corba is ORB, which means Object Request Broker. It is also can be derived from the meaning of Corba. It also uses IDL, which stands for Interface Definition Language. So moving on to Corba architecture and flow. So you might be wondering how Corba works. So first of all, the service will be defined using IDL, and therefore IDL will be translated into two things, which is client stub and also server skeleton. ORB will handle its communication and request routed to correct object, and therefore response will be returned to client. The key feature of Corba architecture and flow is that language independent communication. So here is the example of Corba. On the left side, we can see the IDL coding. It's about module finance app, interface account, and also double check balance. So in this case, IDL defines service interface. It can generate codes for Java, C++, and COBOL. And overall, it supports heterogeneous system. So moving on to advantages of Corba. So here are some of the benefits. I'm sorry. Here are some of the benefits for Corba. Which first one is cross-platform interoperability. It also supports multiple programming languages and it is highly scalable for enterprise systems. It is also useful for banking systems, telecommunications, and legacy system integration. So here are the technical comparisons if you want to compare between RMI versus Corba. So if you look into five of the criterias, which is architecture, language support, deployment, scalability, and best use. In terms of architecture, RMI is JVM based, while as for Corba, it is ORB based. In terms of language support, RMI only supports Java, while for Corba, it is multi-language. For deployment, RMI is much more simpler, while for Corba, it is much more complex. And in terms of scalability, RMI is medium, while Corba is high. So the best use for RMI is Java system, while for Corba it is heterogeneous systems. Therefore, we can see that Corba is much more complex in terms of all the five criterias. So after we have known about RMI and Corba, when do exactly do we use both RMI and Corba? For RMI, the suitable situations will be entire system built using Java. It is also faster development required, simpler deployment preferred. There is also internal enterprise applications and medium scale distributed system. For example, let's just say we want to do university management system by using Java servers. So it is much more preferable for us to be using RMI. And as for Corba, some of the suitable situations are first, when there is multiple programming language involved. There is also legacy systems that needs integration, when there is also a large scale distributed systems and cross-platform communication required. So for instance, we can say that if you want to build a banking system using Java front end and also C++ back end, since as what we know, Corba can support multiple languages, while for RMI it only supports Java. So let's move on to one scenario, which is healthcare system scenario for distributed healthcare system. So we were given two scenarios, which is doctor access patient reports using tablet, and the central hospital server stores records. So in this case, RMI rule will be efficient communication in Java on the environment, and as for Corba rule, it connects Java mobile apps with C++ diagnostic systems. And the results that we can get from this is secure and also efficient data sharing. So jumping on to conclusion, from what we can conclude based on what we have learned to compare RMI and Corba, both RMI and Corba supports distributed client server systems. For RMI, it is mainly easier for Java environments and it is also faster in terms of implementation. And as for Corba, it is better for heterogeneous systems and it is strong interoperability support, which means that it is much more complex compared to RMI. So the technology choice, it truly depends on the system requirements that we use, the scalability, and in terms of language compatibility. So that's all from me. Thank you very much.